Now, until now, we've been talking about the domain of the right-hand side and the domain of a solution of a general differential equation. So what happens if our differential equation is linear? Right, so then the right-hand side of a linear differential equation is of a very specific form. Right, and then we can easily check whether the right-hand side is differentiable with y, differentiable with respect to t. Well, basically, if we require the right-hand side to be continuously differentiable function, then it just means that these two coefficients, p of t and q of t, are continuously differentiable functions of one variable. So the question is, how do we find the domain of the right-hand side in this case? But then when we find the domain of any function, we should be concerned with is it possible to substitute some particular values as arguments into the function so that it will break the function, so that the output is impossible to compute, right? So and of course, if you try to assign some specific values to t and y, then since y is just is just here, so nothing can go wrong with y. So you can assign any values to y that you want. So if for a certain value of t the right hand side is well defined, then if p of t is can be computed, then of course whatever value p of t has, you can multiply it by y and then plus whatever value of q of t. So which means that the domain of the right hand side of a linear differential equation is only affected by the domain of the coefficient functions p of t and q of t. Well, and then if you think about it, then it's clear that the domain of the right hand side is really the set of all possible t and y, such that t belongs to the domain of p and the domain of q at the same time, and y is anything. Well, but then geometrically it means that although the differential equation itself, it is not invariant under vertical translation, but the domain of the differential equation is invariant under vertical translation. So if you imagine that the domain of this differential equation is a set, then this set is invariant under vertical translation. So here is an example when this domain is, well, the domain in T is a union of two intervals, but then it means that the domain in T and Y, well, is basically the same. So T has to be either bigger than -2 or less than 1. So we get two half planes and an infinite strip, blank strip, where it is undefined in between them. Well, and here is one more example. Well, sorry, it's the same example. It's just that usually in this case, these kind of two separated domains, they can be treated as two different problems because they're really unrelated. So you cannot, if you start, if you have a solution that, I don't know, begins somewhere here, and then if you just continue that, since it cannot step into this blank spot, it means that it is really independent of a solution that can start here.